Good morning, everyone. Thank you for joining us. My name is Fabrice Messai. I'm very pleased to welcome you to this Copernicus Marine Service online training workshop for the Iberia-Biscay-Ireland-Region. This workshop was initially planned to be a face-to-face workshop, and it should have been taken place in the Canary Islands. But because of the COVID crisis, we had to adapt and to propose you a full online version. So you can imagine how sad I am not to be in Las Palmas right now. But anyway, let me introduce you the co-organizers of this workshop. We are nevertheless connected with Las Canarias because this webinar will be moderated by Josefina Lusto from Plocan, the oceanic platform of the Canary Islands, which is one of the co-organizers. She will be your presenter. She will moderate the discussion and introduce the lecturers. Hi, Josefina. How are you?
Hi, Fabrice. Fine, thank you. How are you?
Fine, thank you. Can you say a few words about this amazing platform?
Oh, of course. Fabrice, Plocan, the oceanic platform of the Canary Islands, is a public scientific and technical infrastructure who manages an offshore platform, a 23 square kilometer test bed, and an observatory with a fleet of underwater vehicles. Plocan provides services to the scientific community and to companies hosting their experiments and their prototype trials. Plocan has a main aim of fostering blue economy.
Oh, thank you, Josefina. Josefina and her team did a huge coordination work with the speakers and the trainers for this workshop. So thank you very much, Josefina. The Cluster Marítimo de Canarias is the second co-organizer of this event, and it is represented by Elba Bueno. Hi, Elba, how are you?
Hi, thank you very much. Fine, thank you.
Would you like to say a few words about the cluster activity? For example, how many members do you have, or what are your main activities?
Yes, the Canary Islands Maritime Cluster is a non-profit innovative business association since 2008. We have more than 90 members, and our value chain is involved in the marine and maritime sector. Our mission is to promote the development and international competitiveness of the maritime sector of the Canary Islands. We hope that the workshop will serve the interests of all of you, and we are here to give you support in whatever you need during these weeks. Welcome, and thank you for coming today.
Thank you very much, Elba. Thank you. So Elba and Carmen from the cluster did a great job to communicate and mobilize a big part of the audience today. So thank you for your support. Last but not least, Vincent is also here with us to complete the hosting team. Vincent worked from the beginning to prepare this event. Today he will manage all the technical issues during the workshop. Vincent, are you ready?
Yes, hello everyone.
Okay, so let's start. As a reminder, the objectives of this workshop is to show you how using the service can be an asset in your daily job, and try to share expertise and tricks and tips to feel more comfortable with the catalog and the data. You were about 400 people registered. We are currently more than 160 people. It's a success for us, and the majority of you are beginners, and it's perfect because this workshop is designed for you. A few words about the timeline of this workshop. Today is the first round, a webinar in two parts. The second round is a practical homework composed of Jupyter notebooks, exercise and tutorial videos. You should receive today the links to access the hands-on exercises on the Jupyter platform just after the session, the webinar. And finally, the third round will be split in two debriefing sessions, the 13th and the 14th of October. If you want to benefit of expert advices during the two next weeks, I encourage you to start practicing the hands-on session tomorrow. During 2 weeks and more, a chat platform will be available to ask questions and discuss about blocking points. And at the end, all the questions collected will be during the practical homework, and the webinar will be addressed to the experts. Okay. So this is the agenda. So during the first part, you will have a general presentation of the Copernicus Marine Service and 2 user testimonies. After a virtual coffee break, experts will introduce you specific products on the Iberia-Biscay-Island area. After each presentation, you will have the opportunity to ask questions with the chat on the platform. Vincent, can you explain how to ask questions during the presentation?
Yes, sure, Fabrice. So as you can see, we have a lot of participants, so you won't be able to speak during the event. But fortunately, on the bottom right of your screen, you have a chat platform where you can ask questions whenever you express the need to ask question. Okay, don't hesitate to ask your question. This training is done for that. Each time you have a blocking point or you don't understand something, ask your question. So to ask your question, you have just to type your message on the chat platform, bottom right of your screen, added by a question mark. Okay, do you see the question mark next to the type your message? After all the question will be recorded in a Q&A chat, where Josefina and Fabrice will choose the most relevant question to display on the main screen, and the expert will answer the question. So as Fabrice told you, maybe we won't be able to answer all the questions, but afterwards, all the questions will be answered by experts during the practical homework. Thank you. Fabrice?
Few words about the survey?
So we will have a coffee break after the general presentation and the user testimony presentation. I will launch a live survey during this coffee break. Please take time to answer. It's very important for us to have your feedback because we would like to propose you the best training workshop and your feedback are very important for us. So please, during the coffee break, take time to answer the survey. Thank you.
Thank you, Vincent. The core of this workshop is the hands-on session. The Jupyter environment is a web-based application which allows us to propose you code in Python to play with the data. The experts have developed 11 Jupyter notebooks with dedicated tutorial videos. You will have 2 weeks to practice before the debriefing sessions. During these 2 weeks, so a chat platform is at your disposal to ask questions. You will find all this information on the manual guide. At the end of the practical period, the debriefing session will be a live meeting to have feedback from experts. And don't worry about the login and password to attend the Jupyter Hub platform. Soon after the webinar, all the participants and only the participants will receive their credentials and the link to access the Jupyter notebooks and the tutorial videos and the chat. Also, I encourage you to register to the service, which is free, but to optimize your practicing on the hands-on exercise, it will be necessary to be registered to the Copernicus Marine Service. Okay. Finally, the workshop could not have been possible without a great team of experts. I call them the Guardian of the Sea. Yes, the real picture is here. So thank you very much, Ana Maria, Paz, Alvaro, Arancha, Silvia, Fernando, y Antonio, and their institution for your passion, your work, and your involvement in this training. On behalf of the whole team, we wish you a pleasant and fruitful workshop. And if you have any question during the webinar or after the webinar, don't hesitate to contact us.
Thank you. So we can start this first part with a round of general presentations about the Copernicus Marine Service. Fabrice keeps the floor for his presentation. Please, Fabrice.
Okay, so let's start with the general presentation of the service. For the sake of people who don't know what is Copernicus and the Copernicus Marine Service, I give a little summary. The EU Copernicus program aims to develop an operational and autonomous Earth observation capacities for Europe through the development of in situ and satellite infrastructures, and also data dissemination by thematic services. The Copernicus Marine Service is one of the 6 thematic services from the EU Copernicus program, dealing with the validation and the dissemination of the marine data. Behind this Copernicus Marine Service infrastructure to disseminate this data, there is a network of producers with centers dealing with satellites and in situ observations. We call them TAC for Thematic Assembly Center, and sensors operating forecasting system. We call them MFC for Monitoring and Forecasting Center. The Copernicus Marine Service is implemented by Mercator Ocean, which is my company. This is the interested entity by the EU Commission to operate this service. So, whether you are a researcher on climate change, an aquaculture farmer, a routing specialist working on a shipping company, an engineer working on the characterization sites for renewable energy, you know that ocean observing and forecasting is an imperative for your job and for all the marine and maritime professionals. The key things to have in mind about the Copernicus Marine Service is this. This is a single access point, which is a website, the marine.copernicus.eu. You will have access to more than 250 scientifically qualified products. This is open and free. With a simple registration, you can access the full catalog. The quality of the data are scientifically validated and qualified, harmonized data with a common format, which is NetCDF. This is a user-driven service. The evolution of the service take into account the user requirements. And in order to support all audiences interested by marine and maritime informations, the service gives access to 3 different levels of information: the core data, the ocean monitoring indicators, and the ocean state report. Let's start with the data, the core offer of the service. The data can come from different sources, from satellite observation or in situ observation, and model data from 3D numerical representation of the ocean. The model data provides information from the surface to the bottom from several years in the past until 10 days forecast. The in situ data come from different international networks like Eurogoose, GCOM, Emonet, or CDataNet. And the satellite data, we are dealing with L3 and L4 processing data, which are or along track products or graded products. Okay, and you can find a lot of information on temperature, currents, ocean color, waves, sea ice, etc. The second level of expertise are the ocean monitoring indicators. These indicators are key variables to monitor the health of the ocean. This information is critical for assessing and confronting oceanic and atmospheric change associated with global warming. They can be used by scientists, but also by decision makers or agencies or the general public, because you can access to the datasets, but also directly to the maps or the infographics. Okay. And and the third level of expertise, the Ocean State Report, it provides a comprehensive and state-of-the-art assessment of the state of the global ocean and the European seas for the ocean scientific community, as well as for the policy and decision makers. Recently, the summary of the Oceans Report number 4 has been published on the Copernicus Marine Service website. Don't hesitate to have a look. And the Blue Book, Copernicus for a Sustainable Ocean, is a report to tell the story of the Copernicus Marine Service to all the citizens, to explain how the Copernicus Marine Service benefits to the world, to the world citizens. Okay. Okay, supporting the users is one of our commitments. You will have access to a unique service desk with people answering your question and give you information on the next release, the problem you may have to access data. Don't hesitate to contact them if you want more information on your relevant data you need. On the website, you can have access to tutorials, online tutorials, and more than 100 use cases. And on these use cases, for example, I can show you some example of use cases on the website. You can find information on different web mapping tool to monitor jellyfish swarms or their drift, to monitor coastal water quality or oil spill risk drift, or application to characterize sites for renewable energy or aquaculture activities. Okay, so it's very important to show you, to share with you this use case, to give you an idea of what the regular users are doing with our data. And I think that's all for me now. Thank you very much.
Hi, Fabrice. Thank you for your presentation. I guess that our experts have been answering the questions already. So if it's any question left, it will be answered lately.
Okay.
So I give the floor to Cedric Jordan. He is a service desk manager at Mercator Ocean International, and he will be your user support expert. Please, Cedric.
Yes, good morning. So just a moment. I take the screen. Okay, can you see my screen with the website? Yes? No? Yes, thank you. So good morning. So I'm Cedric Jordan from the Copernicus Marine User Support. I'm going to give you an overview of the service part of the website. But first of all, we have to keep in mind some keywords of the Copernicus Marine Service. We will find ocean information and data in 3 categories. I will give you detail later. The use is free of charge for all applications. The service is sustained over time, and it is user-driven. So we take into account the user feedback for the future evolution and improvement of the product and services. So first of all, the home page. So here you will find the 3 categories of data and information, and a 4th one about the ocean visualization, but with the online tool. So the first one, Ocean Monitoring Indicators, OMI. You will find here the free downloadable dataset covering the last 25 years and key variables to monitor the ocean trend. So I can open the page here. So you will find variable about the climate change, the oceanic content, for example, sea level, etc. I'll come back to the home page. The second information is an ocean state report. So it's a document created in collaboration with 3 companies and more than 100 scientists. So the number 4 is now available. Here, you click on the icon and you will download it. Up. The third categories of information is ocean products. So here you will find different products, in situ, model, satellite products. So I go to the catalog. On the left part, you can define your search using keyword, regional domain. For example, I took the Iberia-Biscay-Ireland regional seas, and I can choose a parameter variable. So I choose the temperature, and on the right, you will find the products list which match your criteria. So the products are presented in cartouche. Here you can find the identifier below the title of the product. Here, the source. So if it's in situ data, satellite data, or model. Here the data assimilated by the product. Here so this product, this model assimilates SST, sea level, and in situ TS profiles. The list of the variable with the icon information, with a link to the glossary, which with more detail on the variables. The horizontal resolution and the number of depth level, the temporal coverage, and the temporal resolution, and here the area of the product. Clicking on the expert result, you can create a PDF document with the list and the information of this product. Clicking on research search filter, here you will reset your search. For example, I select the first product. It is a forecast physical product over the EB region. I reach the product information page. Each product information page contains 4 tabs. The first one, you will find information about the product with the overview, so description, the references, the geographical coverage, and if it's a model or observation, a product type, the variable, etc. A lot of useful information. You also find the cartouche, and you will find it here again. You can share this information as a CSW document, a PDF document, or just copy paste the permalink. The second tab is about the documentation. Each product has 2 documents linked: a product user manual, which is more a technical document, and a quality information document, which is more a scientific document. Note that this one can be cited when in a publication. The third tab is about services. Here you will find all the means to reach this product. So the WMS here, subsetter, so you will cut the product depending on your needs. So about on the area, the level, the temporal coverage, etc. And FTP, classic FTP access to reach this product. And the last tab is about newsflash. Here you will find all the operational event about this product, this typical product. So, for example, due to upstream issue, there are currently some delays to update this product. On the right, sorry, there is a View Product button. Clicking here, you will reach a tool to visualize the data. You just have to select your data set on the left and developing the dataset name, you will reach the variable available. So temperature, salinity, for example, etc. And you will find an advanced tool here with more functionalities with the transect, with animation, etc. So if I click here, I reach this page. So you can select the date, the dataset, the variable, and at the bottom you have a user guide to find all the functionalities, and there is also a video to give details on this tool. So I come back to the page. Here, of course, you can download the product. So to download the product, you need to be registered, but remember, it's free for all applications. So I click on download the product. I have to give my username and password. I choose the dataset. For example, I choose the daily dataset. Here I can refine my needs, so I can select a part of the area. I can select the time range, the depth, and the variable. For example, I just want to download temperature. So I click on download. The netcdf file is downloaded on my computer. And if I click on download option, you will find information to download the data using a Python script. I click on the view script button. You will find the requirements, the template command, and some useful information. And you will find this information on the FAQ page. I will show you later the FAQ web section. So I come back to the home page. To be informed of information about the product and services, there are several dedicated page. The first one is a newsflash page. So I click on it. Here, the same. So just a moment. You will find the list of all the operational events. So there is currently a problem on the Black Sea bioproduct. You click on the title, you have more details. Here you will find incident, you will find improvement. So for example, there was a improvement about ocean monitoring indicators. You will find the information here. In this page, everything is listed, and you can subscribe a RSS feed to be in real time informed of the update of this page. There is also another page, but dedicated to product improvements only. Here, so you will find only improvements. For example, the update of ocean monitoring indicators, which was on the newsflash page. You will find here more details. A new viewer, for example, information on the July release, etc. So this page is important to have a look on improvements. Also, you will be informed by email, by a targeted email. So you will receive information on a specific product if you used to download it. We try to target our communication, and so you will receive email if you used to download a specific product which is impacted by an incident or improvement or maintenance. So to learn about So to learn about services and product about the Copernicus service, there are several pages. The first one is getting started here. So we'll find a recap of the offer, tutors to search data, to visualize data, to register, and to download products, to learn. So on this page, you will find useful links. So it's important to read it. There is, as I told you before, there is a FAQ page here in the service portfolio menu, technical FAQ. So there are 50 articles on different subjects. For here, you will find, for example, the cartouche description. It could be interesting. You will find also information on how to automate the downloads, what are the limits, a lot of information which is could be useful for your daily use of the services. There is a training and education tab with, the online tutorials. Several tutorials are available for beginner and advanced users. You can sort by the level, the area, or the subject. For example, if I want, I check, Getting started with the Copernicus Marine Service, I click on the icon, and I reach a video to deal with this subject. There is also a use case section here. So you will find a lot of information, examples on the use of Copernicus marine data. Same here, you can sort on the area, the market, the user type, if it's non-profit, public service, etc., or the country. I click on, for example, on this one, and you will find a lot of details about the user data for a specific application. So this use cases page could be interesting to give you ideas, to have a lot of examples, etc. So to register to the service, so as I told you before, it's necessary to register to download data only. So here there is in the menu there is register now. So you click on it. So the registration form is quite long. Sorry for this. It will change in the future. Then you fill in all the information. You receive an automatic email to confirm your email address, and the activation is automatic. And so you can read the service quickly. Now to contact the service desk, there are several means. At the bottom of the of each page, you will find the contact us any question here. So I click on it. A short questionnaire with four question. I submit a request. You give us your name, the category of your question for your training, and you just type your question, your answer, your question here, and we will receive an automatic email, and we will answer you shortly. there is also there is also a forum, and you can of course post your question online. There is also a new service here at the bottom right corner. Here, I click on the fish, and you can send us a message. Same, we will answer you shortly. So it's important to note that the service desk, it's a 5-people team. We are open for office hours, so during the week, and we have to respect commitments and license to answer you. And this document is available here. So you will find here information on our commitments, the service and the service desk specifically. Thank you very much. If you have any questions, don't hesitate.
Thank you, Cedric, for your presentation. I guess all the questions have already been answered through the chat. Please, the participants, do not hesitate to make your question, even if you have similar questions, it will be okay for us. So now I will give the floor to Antonio González Ramos, who will present the first user testimony. Antonio González is a marine senior scientist at the Robotic and Computational Oceanography Division of the University of Las Palmas de Gran Canaria. Please, Antonio. Antonio, are you there? Antonio? Let's see if Antonio is connected.
Okay,
Antonio, maybe your microphone is muted.
And your camera. If Antonio is not ready,
yes, maybe we move on. No?
Yes, we can switch the testimonies
to Ana Maria. Well, Ana Maria Mancho will present the second user testimony. She's a senior scientist in the Instituto de Ciencias Matemáticas of the Spanish National Research Council. Please, Ana, are you ready? Ana, can you hear me?
Hello, can you hear me? Hello?
Yes, Ana is here with us.
Can you hear me? I was talking to Antonio, just in case.
We cannot see you, Ana. Yes, perfect.
Can you see me now? Okay.
Yes, perfectly well, please.
Okay, so thank you very much for the invitation. Shall I start my presentation? I should say that I was talking to Antonio, and well, maybe if I talk to him by phone, he can tune his presentation after me. So, okay. I cannot see my presentation on the screen, so thank you very much to the organizers for this invitation. I am going to talk about an application of EV, of the products of Copernicus, to the Oleg-Naidenov accident. Nowadays there is an increasing amount of data, of ocean data, and in particular the European Commission is investing, as we have seen already, in the Copernicus Marine Environment Monitoring Services that offers accurate ocean currents that are available in open access, and this is available since very recent times from the Copernicus platform that I have marked here. Let's see if can you see the pointer. So this is the website. So the availability of this data that can be conveniently interpreted with dynamical system tools offers new possibility to address important ocean challenges. I am going to explain how this data was used for the Oleg-Naidenov oil spill. The findings I am going to explain in this presentation are available from this article here, were published in this article here in 2016. And the Oleg-Naidenov was a fishing ship that, after refueling 1,500 tons of fuel on Saturday, the 11th of April 2015, got fire in the port of Las Palmas. And the port of Las Palmas is placed here in this area, and Spanish authorities towed the fishing ship out of the port, and eventually on the night of the 14th of April, the fishing ship sank here in this position in waters 2,700 meters deep. So on the 16th of April, several oil slicks appeared on the surface, and then the question was if the oil would arrive to the coast. At that time, there were modest aqua and terra images from satellite that I am showing in this slide, and these images show to be very useful for monitoring this event. In this picture, on the left side, you can see red dots that are confirmed oil spills that were also detected and analyzed from the satellite images, and this was on the 16th of April, so the first day that the oil slicks were spotted on the surface. And also, you can see the green dots that are not confirmed observable data on the images, but eventually those do not correspond to any oil spill. And then the image on the right shows what is seen some days later on the 23rd of April, and you can see the red dot that is also confirmed oil spills. So it was possible to address the questions I have mentioned about if the oil spill would arrive to the coast by using currents data from the EV platform. And then in these images, I am showing what we computed from this data with help of, with dynamical system tools. And there, in this image, you can see that we were able to predict the day of arrival of the oil to the coast. That was the 23rd of April. And also, we also managed to compute the point of arrival, that is the white point, that was very close to the observed one, that is the diamond, the yellow diamond. So alternatively to this, the emergency services were able to acquire a precise knowledge of the event by means of a formidable effort that include flights from aircrafts that follow the tracks that are marked in red and green. The red are the paths that where oil spill were discovered, and the greens were clean paths. And then also the Coast Guard helicopters in blue are marking the paths that were followed between the 23rd of April and the 10th of May. So the idea is that with the support of the currents provided by Copernicus on that I am plotting in this picture here, it was possible also to have an idea if the spill arrived to the coast. One important point is that just with the velocity fields, it is difficult to gain an intuition about the answer to this question. And we use for the analysis ideas coming from dynamical systems theory, and these ideas are the ideas of the presence in the flow of hyperbolic trajectories. So these are areas in the flow that are highly expanding the flow and in some directions that are called the unstable directions that I am marking in red in this figure. And related to that directions, there are mathematical objects that are called unstable manifolds. And also related to these hyperbolic trajectories, there are contracting directions that are marked in blue in the figure I am showing now, and blobs that are in this configuration, particularly the one that I am showing here, that this is an hyperbolic trajectory which is attached to the coast. This brown thing here is representing the coast. So if you can find in the vector field of the currents this particular trajectory attached to the coast, blobs are going to evolve as follows. This blob, which is here, this green blob, it is going to approach to the coast and then it's going to distort and it's going to be elongated along the coast. And this very simple idea, trying to find these objects in the currents, was very helpful for the Oleg-Naidenov oil spill. In this picture here, I am showing that exactly in the coast of Gran Canaria, there was a kind of hyperbolic trajectory as this one attached to the coast. I am highlighting with the gray tones at the background the stable manifold, which is this line here I am marking. And this stable manifold is a mathematical object obtained from the currents that is telling you that the sinking point of the Oleg-Naidenov was in a very dangerous place, but because it was very close to this object, and this object is acting as a highway that is pushing all the material released in this area directly to the coast. And this is what we observed in the following days. For instance, on the 16th of April, we are modeling the release of oil as the green blobs. And you can see that this release is overlapping highly with the observed spill, which is in magenta, in pink. So on the 19th of April, you can see that all the release blobs are tracking exactly the stable manifold and are approaching to the coast, because the stable manifold, as I have said, is a mathematical object obtained from the currents that is attaching everything to the coast, because this point is an hyperbolic trajectory in a reattachment configuration. And then you can see that on the 25th of April, all the blobs are completely elongated along the coast, following the unstable direction, and it is completely following the observed dispersion of the spill, which are these blue diamonds. Yeah, so just to finish, to tell you that dynamical system tools, jointly with these currents provided by Copernicus, are able to provide good insights in oil spills, and that making these tools operational can help to the management of coastal environmental problems. And finally, these were collaborators of this work. So I think I am done.
Thank you, Anna, for such an interesting presentation. I guess we have some questions for you. Not this one.
So I am answering questions in the chat mode.
Yes, we will publish them.
So
there is one question here. Which resolution has been used in your study?
The field had a resolution of
Sorry, Anna. Excuse me. I guess maybe Antonio has got his micro on because we are.
There is a lot of echo.
Yes.
Yes, he has his micro on.
Please, Antonio, can you mute it?
Probably he doesn't hear you. Yeah, I think he cannot hear you. Okay. Okay, the resolution is for 5 kilometers for the velocity fields, but for the mathematical analysis, we do interpolations of those fields, and it seems it is working well to obtain this idea of the hyperbolic trajectory attached to the coast, which is attracting the material towards it.
Okay, let's see, we have another question.
Finite time Lyapunov exponents are similar to the tool, but if you read the article, we published the computation with finite time Lyapunov exponents, and you see that the images are not so clear or not so neat. So the forward time Lyapunov exponents are highlighting the stable manifolds. Yes. And why the authorities not evacuate the functional ships? So I don't know why they act as they did, but I don't know. Lagrangian coherent structures. Yes. This is what we use, the Lagrangian coherent structures. You can highlight Lagrangian coherent structures with different tools. Finite time Lyapunov exponents is one tool, and the one we use is a different one. It is called function M, or Lagrangian descriptors. There is a huge bunch of literature on that. If you want, I can provide it later.
Okay, thank you, Anna. Well, the rest of the questions will be directly answered, so don't worry. Now we are going to, I give the floor to Antonio Gonzalez. As I said before, he's a marine senior scientist at the Robotic and Computational Oceanography Division of the University of Las Palmas de Gran Canaria, and he's going to present another user testimony. Please, Antonio. Antonio, can you hear me?
Can you listen me?
Yes, perfectly well.
I cannot listen you, Josefina, so I think it's better just to put my presentation and I can just begin.
Okay.
First of all, I would like to thanks to the organization of this meeting, especially to Fabrice and Vincent and Josefina for the job done, and mainly to the Spaniard team of Copernicus, led by Puerto del Estado, by Enrique Fanjul, Begoña Pérez, and Marcos Sotillo. In my case, I'm just a senior lecturer at the University of Las Palmas de Gran Canaria. I'm just working in a division of robotic and computational oceanography, and we have also a transversal lab called Sigma that lead us the possibility just to put to some units, especially 3 divisions and 15 groups of research of emergent vehicles. Our lab have 3 axes. We have an axis of remote sensing. We began to work on remote sensing on 1996. We have a bundle antenna, so we have been working alone for with about 28 satellites. Nowadays, we are just developed, implemented in our lab, all the downstreaming of the Sentinel-1 radar A and B data, Sentinel-2 A and B, and the moderate resolution Sentinel-3 A and B, and we have access to the data from Landsat 8 and MODIS, Terra and Aqua, and both beers. We also belong, as I have just said, to the core group Copernicus, Spain, led by Puerto del Estado. So we have access to different domains, local domains with a resolution of 60 meters in the port domains. We have also access to the moderate resolution of 300 meters in some domains around the Canary Islands. And we have also access to the EB and global Copernicus data that are the data used for the navigation of the gliders. And finally, we have marine robotic units, as I have explained. We have access to, well, we have 5 units. We have 2 gliders, deep gliders, that I will explain later the configuration. We have a G500 in AUV that we are just developing with the University of Girona, and we have we are building one ASB that is very near to leave the kitchen, and another operational, the G2 at Irma, that is an autonomous underwater vehicle developed by us. Well, as you see in the central slide up, we have been working with the Challenger mission that is led by Rutgers University in New Jersey in the USA. You can see that we participate with Teledyne Web Research in spite of Rutgers and us, Teledyne Web Research, University of Sao Paulo, Cape Town, University of Perth, University of Sri Lanka, and we have 2 Plocan too in the team. And we have run later 2008 about 12 missions. I have to update this graphic. We have spent about 90 months at sea, and we have run about 80,000 kilometers. So that means that we have got and collect from the ocean about 50,000 TS profiles. We began with RU-28. We lost very near the Azores Islands, so we tried again in 2009, and it was the first autonomous underwater glider that crossed the ocean. We received it in Bayona in Vigo in Spain, and then we fly to Silvo from Islandia, Azores, Canary Island, and then Barbados. And in 2017, we flew Silvo from Boston to Ireland, Canary Island, Barbados, and I have to update Bermudas. And some weeks ago, he was recovered in Boston, making his second circumnavigation of the North Atlantic. And we have also circumnavigated the South Atlantic with RU-29. We began in January of 2013, and we got it in March of 2006. So this mission got us about 3 years. Well, I'm just talking about the Silvo USA Island leg because we used the Lagrangian skeleton emergent techniques that has been described by Anna. Basically, it's based in using some. Let me go to the previous one. Here you have in the upper slide that the Lagrangian skeleton of the ocean, we have integrated all the speed and the direction in the first kilometer of the water column is the flight domain of the glider. So we have calculated a promediate field of speed and direction, and with this we have applied the function. The M function is an emergent technique of the dynamical system theory just described by Anna. So the ocean seems to show some special points and meeting points called hyperbolic points that can be, in this case, it's a saddle hyperbolic points where the fluxes describe a trajectory going to the point. They are stable manifolds, and look that in latitude to the north and to the south describe what we call unstable manifold. So the fluxes goes to the center just in longitude and in latitude. Sorry, in longitude, and it goes to out in latitude. So we take advantage of this point just to describe the waypoints where the glider arrived by the stable manifold going to the point, and we leave to the next waypoint using the unstable manifold. Here you have in the second graphic the real path of the glider, and here you have some of the structure described with the Lagrangian skeleton, where we were just point successive meeting points, waypoints, to increase the speed of the glider and to move to the east as soon as possible. If you wish, would you mind, Sam, to put the video in the next? Well, here is the glider just leaving the continental shelf. Look, it's in red. We were not using still the Lagrangian skeleton technique. So now in blue, we are just using it. Look that we make a back and we put the glider at 1 meter by second. So we began to call him Usain Sealbolt because he was the absolute record of the deep glider that got more than 1 meter by second to fly to the east. Okay, well. However, we are just really very interested with the glider in the regional domain. We have been working during practically 25 years in our FAC in the change that we have observed very near to us in a very singular area, the Northwest African upwelling system that in the framework of the export project of the NASA is one of the singular hotspots to control or to monitoring what is happening and what will happen with the ocean the next decades. Here you have down a little slide where we can just got the SST changes by decade. Look that in some places the increase is about 1 degree by decade. And we have observed too that there is some areas that becomes a little bit porous, I mean more oligotrophic in blue, and some of them possibly due to the change of the wind path and the intrusion of dust, they seems to increase like this in the Cape Land upwelling. It seems that all the production seems to drop, and however, in this case, the primary production in the Mauritanian upwelling seems to increase. That's one of the reasons is based if we dip a little bit and we eliminate the first 100 meters of water, and we get the salinity field, for example, at 150 meters. We can target the frontal line described by the central North Atlantic, described here in more salted in red, and the South Central Atlantic that you have here in blue. I have got from the Copernicus system the frontal signal described between about the isoalin of 36, and you have here the result. We have got a point here very near Cape Verde, and you can just see that the presence of the southern water in the eastern side becomes a little bit more present the last year. So that means that we have a reduction of the salinity near the coast and the presence of some lines of this deep and productive water moving to the north. So possibly it will be associated to these green points that appear here, just an increase of the fluxes due to the central southern water. To answer to this question, we request a project called Fluxes. It's a national project, coordinated project of excellence given by the Ministry of Economy and Competitivity. We finished the last meeting in January, and we are just trying the information, but our main objective was to calculate the ratio between the particulate and dissolved organic carbon, the distribution at the meso and submeso scale, the inputs and outputs, and for that we applied 2 research quizzes on board of Sarmiento de Gamboa, one in July and the second on the right in November. We used 2 gliders, a multiparametric CTD, CSOR, LA DCPs and DCPs, turbulence profilers on board of the gliders and on the board of the ship, cameras, hyperbaric cameras, spectrometric and laser analyzers, CSOR, isotopic gases, and so on. On the right side, you can see the second window. We got a mesoscale window, and you can just see little tracks that were done by the ship, just with throwing the CSOR. We got here the mesoscale. We made another little window to determine the submesoscale, 2 biochemical paths here in black. And here you have the real path of the gliders in white. We deployed them just before to got the window, and then we spent about 18 days just flying the same path, followed by the ship in the biochemical transit. We put both gliders with a current corrector to go straight ahead along the path, the biochemical path, with some hours of in a defilant orbit on defilant path, with some hours of difference between both gliders. About the configuration of the glider, here on the left you have the real path of both. We have 2 units. We made about 35 350 kilometers of both gliders, so we complete 700 kilometers with both. We spent 18 days, and here you have up the configuration of DINA. DINA is a dynamical oceanography glider that has on the top a microrider of turbulence. So we put the microrider active in the first, second, and third clean bin, and we connect the Doppler in the first, second, and third diving. Each hour he emerged for 15 minutes, he get a GPS location, he send and receive information, and then he come back again to dive again for each 8 hours. Bio, however, is a bioptical glider. He has a CTD, full resolution. I mean, it was activated in all the diving and cleaning. He has an oximeter and a fluorometer. He has 2 fluorometers, a phycoerythrin and chlorophyll fluorometer, and a backscatter fluorometer. And here you have the window just over the frontal of Cape Verde. So we can see that it's practically symmetric in latitude and longitude to have at least the equal quantity of northern central Atlantic water and southern central Atlantic water. Well, here you have the previous results. Look that Bio and DINA got, here you have the temperature up, Bio and DINA, and down the salinity. And you can see that we got about 750 profiles. The ship got only 75, so we can say that we got practically 90% more than TS profiles than the ship. Here you have some of the profiles where you can see that practically there is little change. So when the glider dive and climb in the same position, we have about in this market here about 1 hour of difference. And look here when we calculate the difference, how pretty change this area. Is a very dynamic area. So in some cases, with 40 minutes, between 40 minutes and 1 hour and a half of time between the diving and the cleaning location, we found difference upper of half a unit of salinity and half a unit, half a degree of temperature. So it's indicating the great change of the great dynamic of this area. And look here that we observed during the transit, the biochemical transit, free intrusion of southern water, less salted, in the upper water, just the first just at the beginning of the mission, a second intrusion here in the center, and a third one just at the end of the biochemical path. Well, here you have some shots that we got in real time from the seashore. So we plot on our app flying. So here, just in the middle of the flight of the glider, you can just see them just flying here. This line means the 1,000 meters on the bathymetry. So it's a risky area for flying the glider at depth. So in this case, look that all the window was out of the bathymetry risk. And we have a landscape up fluorescence and down fluorescent at 50 meters and down the salinity at 150 meters got from Copernicus. And you can see that we see the landscape in the seashore very similar to this reported by the glider on the ground. Here you have on the right side the salinity map. Down you have the oximeter. Look how pretty well you can see how the structure, I mean these intrusions of southern water agree with the minimum of oxygens in this free location at the beginning, in the central of the geochemical path and on the right. Okay, and here you have the chlorophyll, where you can see that an intrusion is associated to these entries of southern water in the upper layers and in the border of these intrusions. We have also done a very nice exercise comparing, because in the biochemical path we have data from the ship, we have data from the seashore, and we have data with the glider, and we have the model. So we have on the left the temperature transit, the biochemical transit, and on the right the salinity transit. Look, the Mercator up on the left, temperature, on the right, salinity. The second is the ship, the CTD of the ship, temperature on the left, salinity on the right. the scissor that only fly at 400 meters, and look how pretty well you can see the same structure using, in this case, the gliders. So the gliders, just concluding, so the scissor, the glider and the scissor, so captured the smallest scale with the greater resolution. The high complexity really is need or required of very fast sampling methods because of the variability of this area. But the glider show with the finest spatial resolution. We have a TS profile each 1.5 kilometers approximately, and the scissor the fastest method just to get it. Just as a scientific pre-conclusion, we can say that we have found the free intrusions of the less salted and colder sulfur Atlantic central water with a minimum of oxygen concentration into the more salted and warmer North Atlantic central water. I have just included to you some papers. If you want to see, for example, the paper of the glider, it's in the number 5, sorry. Number 3, sorry. You have here in the number 6 the Marine Copernicus monitoring led by Karina von Schuckmann, a paper that was published in 2016, and some papers that can interest to you. And finally, thank you very much. Here you have a slide and the YouTube video of the last mission that we completed in 2016. It was the first circumnavigation of the South Atlantic, and some YouTube videos where you can just see the cube of data of Copernicus that we use in this mission. So thank you very much, and I'm just open to any question that you want to do.
Thank you, Antonio, for such an interesting presentation. We have some questions for you. Antonio, which product of Mercator did
I cannot remember now the resolution, but we have been working with the global model Copernicus, so I presume that they have 8 kilometers per 8 kilometers of ground rest.
Okay. Have the results been published, Antonio?
Not yet. We are just working on. I have just said that we finished the project in 2019. We are just forcing to our students, PhD students, just to publish some of the results, because we have had a lot of job of work just to correct the TS coming from the glider, because the glider have a problem. He get the TS data with a frequency of 0.5 hertz, so that means a data each 2 seconds. So when you are just trying to correct the temperature and then the salinity, there is some problems, because sometimes this difference is less than 2 seconds. So we have been practically working for some months with this, and finally we have sorted out, and we expect to publish this in this year and the next.
Okay, which satellite data?
For satellite data, we have all the artillery of data, but usually we use the temperature and the chlorophyll maps just for the real time. Level 3. To the next answer, level 3.
Okay. I guess that's all. Thank you very much, Antonio.
Thanks a lot to you, Josefina.
Thank you. Now we have a virtual coffee break. I remember the participants that it's very important for us to have their feedback. So please take a look at the survey. It's very short and it's very important because we want to improve. Fabrice?
Yes. Thank you very much to all the speakers for this first part. We hope this first part has given you a good overview of the Copernicus Marine Service and the benefits of using it. So as Josefina said, it's very important for us to complete the survey for us, because we use your remark and your feedback to improve this kind of workshop and also the service. So we can be back in 15 minutes for the second part. But in the same time, for people who are interested, I can show you some. I can share my screen to show you what you can access on the Jupyter platform with the credential you should receive after the webinar. So I would just try to share my screen.
Fabrice, they are asking where the survey is. Can you please?
Oh, the survey is normally you have access on the survey directly on the screen.
Can you listen me?
Yes, Antonio. Okay.
Can you listen me?
Perhaps we have to do that and that. Okay. So you should have the survey. Yes, Antonio. Do you want to add something? Okay. So I don't know if I take the lead on the screen to share my screen and show you some website, or if I let you answer the survey. The following session I'm going to present you is an option for you. Okay, the second part will start at 11:30.
If you don't mind, Fabrice, we will leave the participants answer the survey.
Yes.
Oh, okay, thank you.
During the second part of this meeting, you will have a presentation of the products for the EB region by the different experts and an introduction after each presentation on the Jupyter notebooks for the practical session. Hi, Arantxa.
Hi, hello.
Okay, we will close the survey in a few minutes.
Okay.
And then I would just share my screen just to show the participants where to find the Jupyter tutorial videos and how to access the Jupyter Hub.
Okay. So after that, you will connect with me? Yeah, I suppose.
Yes.
Okay.
Josefina will introduce you.
Okay.
So
I think that I shouldn't touch the video or the audio connection because you do that, or
yes.
it's automatic. I don't.
Yes.
Okay.
So quickly, let me share my screen. I guess you have time to answer this survey.
I got the...
Okay, guys, participants, I will stop the survey and Fabrice will make his sharing screen now, okay?
Okay, thank you. So as I said before, it's an optional session. It's just a plus for this webinar. So let me okay. So this is on my other screen. I can share with you. Okay. So you should receive a link to access this manual. So this is the participant manual. You will find all the information to practice the hands-on exercises. So you have information about the co-organizers and the speakers. And after, you have a part dedicated to the introduction of the tools and platform, okay, about the Clip Meeting webinar tool and the Jupyter Hub environment, okay. So after the meeting, maximum 1 hour after the meeting, you should receive credentials just for just to log the Jupyter Hub platform. This is completely different credential to access the Copernicus Marine Service. So you have to register on the Copernicus Marine Service if you want to optimize your experience. So on this Jupyter Hub, you have some screenshot to explain you how to do that. So if you want, for example, I try to zoom a little bit. Okay, there is instructions to explain you how to copy a folder of Jupyter notebooks on your home on your Jupyter Hub. So you have just to copy this line, and I will make the presentation. I will make the explanation in the same time. So for example, I would like to copy the physical model product. So I take this line, okay, I copy all this line. So I copy this line, and now open a new tab. I'm going to the, sorry, Jupyter platform. So I'm already logged on this platform. Okay, and now I'm here. Normally, you access the platform and you are connected with your account. So it's your home, and you have shared notebook here, training EB, and here you have the list of the different notebooks, the folders with the different notebooks. And now it's simple. You just open a terminal, double click, okay, and you paste the line from the manual. Enter, and then it's okay. The notebook is copied on my home. So I came back here by clicking here. It's here, okay. Jupyter Notebook, Physics Model Products. I double click, and there is the Python notebook, the Jupyter Notebook here. I double click to open it, and I can start to run the Jupyter Notebook. If you are not familiar with this kind of notebook, I engage you to see the tutorial videos. So again, in this email you should receive after the webinar, there is a link to access this channel on YouTube, and you have different tutorial videos dedicated for each Jupyter notebooks. So you can see, for example, if I want to launch the physical model product, okay, this is this one. So I click. Okay, and I have the recording video of Alvaro de Pascual explaining how to run the Jupyter notebook. Okay. So I can listen Alvaro and can see his explanations live on the Jupyter Lab. On this playlist, you have also some interesting videos on how to download the Copernicus data, getting started with the Copernicus Marine Service, an introduction to the Jupyter Notebooks environment to understand the ideas of the different cells, to run step by step the Jupyter Notebooks, etc., etc. Okay. So that's it for the Jupyter Lab. So I can close this. You will access also a link to the general presentation, to all the presentation we provide during this workshop. So you will have access to this storage, and this is the chat platform to ask your question to the experts. So again, on the manual document, you have all the explanation to access the platform. You will have to reset your password, and you will be able to access this platform. So you have different channels related to the different notebooks, and you can ask directly your question to the experts. Okay. So that's it. Once again, after the webinar, you will receive your accounts for the Jupyter Hub, and also the accounts will be created for the chat platform. So don't try to access now because you don't have the login and your accounts are not created. But 1 or 2 hours after the webinars, you will be able to access. And if you have any problem, don't hesitate to contact us at training CMEMS at mercator-ocean.eu. Okay, so I can stop my screen sharing. Okay, that's it. And now we're ready to start the second part in a few minutes, in 2 minutes. Okay. Yes, I answered the question of Ellie. You have to create your own accounts on Copernicus, on the Copernicus Marine Service. Yes. So the URL, okay, the link to access the playlist with the tutorial is this one. But again, after this this webinar, you will receive an email with all this information. Okay. So yes, Ophélie, you have to create new accounts.
Shall we begin, Fabrice?
Yes, we have 1 minute. So, Arantxa is ready.
Hi.
Hi, Arantxa.
Okay.
So, okay, let's start the second part.
Yes. So we start the round of presentations of products available in the catalog of the Copernicus Marine Service for the EB region. I will give the floor to Arantxa Amo and Álvaro de Pascual. Arantxa will present the physical wave and bio, and Álvaro will give a brief description of the hands-on session. Arantxa is currently responsible for the maintenance and monitoring of the IB Monitoring Forecasting Center operational suites and user support, and Álvaro is member of the same center, and he has a wide experience in modeling applied to ocean and atmosphere. Please, Arantxa.
Hi, hello, good morning. So, if I can see the presentation, I see it, okay. Can you move the video to the corner? Because it's over the slides. Well, first of all, this is the area that we are giving service, the EB area. EB stands for Iberia, Biscay, and Ireland, okay? It covers the eastern northern Atlantic Ocean that goes from the Canary Island to the Irish Seas, okay? It covers a region that goes from the 26 degrees to the 56 degrees in latitude, and in longitude from -19 to 5 east degrees, okay? So this is a region with a complex oceanographic processes, as you can see in this scheme, in this image. Two of them, to give an example, are one of them is the coastal upwelling that has important relevant socioeconomical impact in the region and affects to the north coast of Africa and also to the Iberian Peninsula coast to Portugal and to Galicia. And then we have also one of the most complex spots, oceanographical spots in the world, the Strait of Gibraltar. In only a strait of 15 kilometers wide, we have a exchange of water masses from the Mediterranean Sea and the Atlantic Ocean. So, in order to give you the most possible realistic view of all these complex processes, the EB service is using state-of-the-art regional models, okay, the best possibles nowadays. So we have models for the three components, the physical, the bio, and the waves. In case of the ocean physics, we use NEMO. In case of the bio, we use Pisces, and in case of wave, we use one model, okay? But the ocean is not, it's a connected system. You cannot model it physical component without interacting with the bio, for instance. So all our efforts are going in the direction of trying to couple all the systems. Nowadays, we have the bio model, Pisces, that runs online couple simultaneously with the NEMO, with the physical model. Also, we have coupling between the waves and the physical components, but this coupling is offline. I mean, the physical component generates the currents, and the currents fits the wave model. Okay, so they don't run simultaneously nowadays. In the December release, I'm going to mention several times during this talk the December release because it's very near, it's very close to the present time. In the December release, we are going to implement the two-way coupling between the wave and the physical component. That means that the waves are going also to force to the physical model, okay, through some parameters. So in order, well, we are a service. So if you are a service, you have to maintain 4 main processes on a daily basis, okay? These 4 processes are the following. So we have to acquire upstream data, the best available, and this data has to be on time to execute the models. When we execute the model, we have to generate the products, but the products, they have to be delivered in a certain format, in a user format. Also, the results of this model has to be validated. We cannot deliver anything. We have to deliver products with quality, okay, with a validated quality. And then the last step is deliver the product. But this product have to be delivered complying with certain target times. So we are obliged to deliver the products at a certain times, okay? So If we complete successfully these 4 tasks, then we have a highly reliable service. And we can offer you from the point of view, from the view of the literature, the scheme that I showed you before with all the processes that take place in this area, to this more realistic view of the ocean that you can see now in the presentation. Well, all this work is done thanks to a team of more than 20 experts. So these 20 experts are working in 7 different institutions, universities, public companies, private companies, etc. The coordination, the coordination is in the hands of Port of Spain. Okay, the EBMFC service desk is the one in charge of coordinating. Is the link between the operational team, the ones in charge of maintaining all the operative tasks, the things I explained before, and is the link between the operational team and also and with the central service desk and also with the users. But all this work is impossible to be done without the support of the computer team. All our models are run in Finisterrae 2, that is a supercomputer that is located in Galicia, in CESGA. Okay. Then we need also a team in charge of the transition into operation, because we are not a static service. We want to evolve. We want to improve in time. So to offer you better products. So we need to have a team that is dedicated to translate all the developments that the R&D team are proving, are testing, to the operations. Before doing that, before this transition, all the products needs to be validated. So we also need a product quality team. A part of this, the EB service is also involved in other activities, cross-cutting activities, and in other projects. Well, this is what I explained you before. We need a support for the supercomputer resources, and this is provided by CESGA. Just to give you an overview of the importance of this support, in the last year, the EB service need more than 1 million hours of PCU or CPU time to complete their operations, generated more than 50 terabytes of data. Only in one run for running the daily near real-time physical forecast, we need more than 1,000 cores during 3 hours of time. And we generate more than 1 terabyte of raw data. So if we take into account the different components and we take into account the different updates of the data, we need to launch 25 EB cycles every week. So it's very important to have a robust machine. In this case, Finisterrae 2, that is the shared machines, so it's not dedicated, so we have to make reservations for the computing resources in advance. Well, this is an overview of the products that we are delivering. It's an overview of the evolution. We began with only 7 datasets, and nowadays we are delivering 20 datasets. We deliver in the 3 components, physical, value, and wave. We deliver the 2 kind of products, near real time, also multi-year. In total, we deliver 37 variables between the blue and the green ocean, temperature, salinity, waves, chlorophyll, nutrients, oxygen, and in a wide range of temporal frequency. We deliver these variables in monthly, in daily, in hourly, in even, for some variables, even in 15 minutes dataset, in 15 minutes average, okay? So this is only a summary of the panels that Cedric has explained before with all our 6 products, okay? And here you have more detail on the system that generates each of these products, okay? First of all, the models, I said before, NEMO, Pisces, and WAM, okay? The main difference between the near real-time and the multi-year products currently is the resolution, the spatial resolution. For the near real-time products, we have a resolution of around 2-3 kilometers, depending on the latitude, okay? But in the multi-year products, we have a worse spatial resolution of 6 kilometers, okay? So the next thing to mention is the data assimilation. In the physical component, we have data assimilation for both type of products, for multi-year and for near real-time. We assimilate observation for altimeter data, sea level anomalies, also in situ temperature and salinity vertical profiles from the Cora products, and sea surface temperature from satellites, the Ostia products, okay? So in case of the bio, we don't have still data assimilation in the bio component, the bio system, but the bio system runs coupled to the physical model, to the physical system that has data assimilation. So well, in the future, I suppose that we will try to assimilate chlorophyll for the bio. And finally, the wave model. Now they are very different. Okay, the near real time has better resolution, 5 kilometers, whereas the multi-year has 10 kilometers of resolution. Okay, the near real time is offline force with the physical surface currents, as I explained before, and also assimilates that, assimilate the sea wave height. Okay, but this is going to be solved in a few months in the December release again, the next release. The multi-year wave product is going to have the same resolution, is going to be offline force by the current from the multi-year physical products, and it's going to assimilate data. So they are going to be more or less similar. Also to mention that in the December release, the current multi-year product for all the components are going to be updated completely. So all the catalog has been forced with the 1 hour ERA 5. Okay, it's one of the improvements. Well, this is a summary of the different data sets that we have in each of the products. Okay, so let's begin with bio and also the variables. With bio, in bio we have 13 variables, okay? Nutrients, aphotic zone, phytoplankton, also carbonate variables, sea surface, partial pressure of CO2, dissolving organic carbon, etc. In the multi-year product, we will have these carbonate variables distributed in the December release. Now, currently, they are not distributed in the current multi-year bio, but in the December release, they are going to be included. In the bio, we have daily and monthly data sets, and all the variables are in both data sets. Okay. In case of the wave, products, we have 17 variables related to the wave height, to the period, and to the direction. We have only one data set, the only one, because their data is not average. We are giving instantaneous values centered on the hour. Okay. In all of these products, you will see that there is always one data set that is common, that is the static. In the static data set, you will find the bathymetry, mass, coordinates, the files, the input for the models. Okay, so you can have it also. And just for the last is the physical component. That is the one that has more different data sets. You have here a table where you can find for which variables you have the different temporal resolutions. Okay, you have hourly, daily, 15-minute data sets, but maybe one of the most important, or maybe one of the most useful for you if you are working with coastal models, could be this data set, the hourly 3D data set. This data set provides you temperature, currents, and salinity with hourly values, average hourly values, but in the whole column of water. So you have from the surface to the bottom of the ocean. So this data set is very interesting if you want to nest to the EV solution, your coastal models. It has a little bit problem that the product that it generates, the file that it generates, are very heavy. So it's not possible to provide you this product in all the area. So we have selected these more coastal areas, and we are providing this product only in these areas. Okay. So as it's very heavy, it's not possible to maintain 2 years of data in the Copernicus Web Service catalog. So you are only going to have there 1 week. the last 1 week. So if you are interested in this product, we warn you, we advise you to have a daily procedure to download every day the files and to store in your machine, okay? Well, this is only a warning, because in the December release, we are going to implement the change in the product dataset names, okay? The change is going to be very direct. There is a straight correspondence between the old dataset names and the new dataset names. The only thing is the new dataset names are going to be more meaningful. It's going to give you more information about the dataset you are going to download, okay? This is only to show you a little bit of how the data is delivered. If you are going to download the data through the FTP server, then you are going to get the data as it is produced, okay? We produce 1 file per day. This is the way in which we produce the data. So here you have an example for the physical near real-time data set for the daily one, okay? So you will have here the name of the file. You have here the information of the system, of the component, of the kind of product near real time, of the kind of data set, daily average, and also you have here the date of the data, and here you have the bulletin date, or the day when the file was produced, and here the forecast horizon, okay? If you inspect the header using the nc-dump command, you will see the variables that are distributed inside. Just to warn you also that the values are given in packet format, but this is no problem for most of the visualization tools that you are going to use, because they do the transformation and you visualize the data as it is. So usually there are no problems. And also you have global attributes with more general information of all the file. Okay. Well, I forgot to tell that the format in the December release, all the products, all the data sets for the EV will be given in NetCDF 4, okay? Currently, there are some data sets that are in the 3 version, but this is going to be fixed for the next release. And this is to explain you the target delivery times that we have to comply with. In case of the multi-year, we don't have target delivery times. It's a static product when it's delivered. And well, you have this product from 1992 to 2019, okay? In the next, well, I will explain that after. In case of the near real time, for the physical component, we deliver daily products before 2 o'clock in the afternoon, okay? In this delivery, we provide you with 1 hindcast of the previous day and 5 forecast days. Okay, so in the next cycle of the physical run, the forecast will be replaced by the new ones. Okay. We also have 2 weekly analysis runs that they are going to replace the hindcast and they are going to conform the historical catalog. Okay, only 2 years are maintained in the Copernicus catalog, so older files than 2 years are deleted. So take care with this. In the case of the bio product, it's weekly run. Okay, it runs on Thursdays, and the forecast is delivered before 6 o'clock in the afternoon, and we deliver 1 hindcast from the previous day and 10 forecasts. Okay, 10 forecast days. Also, we have a hindcast run, a weekly hindcast run that runs coupled with the physical analysis run. And it's the ones that creates the historical bio catalog. And finally, we have the wave component. In case of the waves, it's a little bit different. We have 2 runs per day. The first run is in the morning, and the second run is in the last minute of the day. In the first run, we generate 1 analysis from the previous day. Here we have data simulation in the daily runs, and we also generate 5 forecast files. In the afternoon cycle, these 5 forecast files are replaced, are updated with the outputs of the second cycle of the waves. This is because we have at this moment better atmospheric forcing, so we take advantage of that. Well, this is information for the next December release. In case of the multi-year products, I told you before that we are going to deliver new completely multi-year products. Then the catalog, the historical catalog, will begin in 1993, okay, instead of 1992. In case of the physical and the bio component, this multi-year product will be updated from December release through the interim system. It's a new system, okay. And in case of the multi-year product for the waves, it's going to have a lot of improvements. It's going to be more similar to the near real time, okay. And it will be updated twice a year, typically. And in case of the near real time wave component, the second cycle of wave is going to extend the forecast horizon from the 5 forecasts to 10 forecasts. These are the main novelties. This is a more detailed explanation of how the historical catalog for the physical near real time product is generated, is produced, okay? So I explained it before, the forecast day cycles, but in case of the analysis cycles that are weekly performed twice a week, we have our first analysis cycle on Wednesdays afternoon, and they are going to generate analysis for the week before. And then we have the next Monday, we have another analysis cycle that will generate the definite catalog. And it runs the week before the last week, okay? But all this information is in the document, so you can take a look with calm. This is the interim system, the one that I mentioned before, is the new system that is going to update the multi-year bio and physical products. The idea is to bring, the idea behind the interim is to bring the multi-year product closer to the present, closer to the near real time. So the idea is to monthly update the multi-year product through this system, generated data from the month before. And also we will execute an update of the last year twice a week through this system. So this is a summary with the links from where you can get all the information of each product. You have there the product user manual and the quit document. So if you want more information about what I told you before, you have almost all in the PUN document. This is a summary of how to get this information, but Cedric has explained it all before. It's not necessary to repeat. Well, but the EB service is not only producing products, but we are also involved, and we also participate in the publication of the Ocean State Report, okay, and in the creation of added value ocean monitoring indicators, the OMIs, the OMIs. Currently, the EB service has 4 OMIs available to users in the Copernicus catalog, and they are already published in the corresponding Ocean State reports. Some OMIs or some index are related to the processes that I explained you before in the first slides. For instance, we have one index to monitor the EB coastal upwelling. Here you have this, okay. Other index are more related to extreme variability of some variables as temperature and wave height, okay. And for the next year, well, for the next December release, we are going to introduce another index, another indicator for a strong wave incident. Yeah? And the next year, we will, it's already proposed for the next Ocean State report, we are going to introduce the first bio indicator. Okay. So, well, all these, currently, the ocean forecasting system are used as tools to support the decision-making. So it's of vital importance to have a good skill assessment of the result of these services, of these systems. In case of the EB service, we use an internal tool, the NARVAL tool, that it allows us to produce online and delay validations in online and in delay mode with all kinds of observations, since in situ observations to remote sense observations with satellite data, with radar data. And also the EV model is validated with other models that maybe overlap in the area, the Mediterranean model or the Northwest Shelf, okay? So with this tool, we try to measure, to have a control, to monitor the quality of all our results. Well, if you want more information related to the quality of our products, you have three main sources. The quit that I mentioned before, the Copernicus validation website that I think is going to be improved soon. And also I leave you here a list with scientific literature for the EV products, okay? If you are interested on that. And well, I said before, I think that we are not a static service, but we are a service on evolution, on continuous evolution. So we are trying to improve continuously. Nowadays, our research and development team is working in several upgrades. One of them is try to improve the models through the increasing the resolutions, adding more processes. Also, the first steps towards the addition of data simulation for the bio component is on process, is working. And well, trying to couple between the different components, okay? And so trying to generate new multi-year products that have the same grid as the near real-time one. We try to approach both type of products, the near real-time and the multi-year. And not only we have to monitor the quality of our results, of our products, but we also have to monitor the whole service, all the phases of the service. Since the download of the forcings of the upstream data that we need to feed the models, all the phases, the different phases of the execution of the operational suites, the dissemination, the data storage, the validations. So we do that thanks to two tools, the eThink and Grafana. Thanks to these two tools, we have a monitoring, or we have every process monitored. In case something happens and we cannot comply with the delivery times, the EV service desk open an incident. This incident is managed by the central service desk and informed to the users. And also we have to comply with the times that I told you before. So all these requirements at the end results in a robust and fully monitored service. And just to finish, only tell you that the EV community is a growing community. Last year, we had more than 400 users, and half of the users came from the public sector and universities, and more than 30% came from the private sector. But we don't care where are you from. The EV team is always happy to see that you are interested in our products. And we are pleased to help you with any doubt, any problem, any issue you have in the download or when you work with our products. So thank you very much for your attention. So Fabrice. Hi.
Arantxa? Yes, we give the floor to Álvaro.
Hi, hello.
Arantxa, can you hear me? Arantxa, can you hear me?
Yeah, I can hear you.
Yes, we can give the floor to Álvaro.
Yeah, okay. Thank you.
Thank you for your presentation.
Thanks.
I cannot see you. Can you hear me, Álvaro? Well, I guess there is some problem with Álvaro. Maybe we can answer the questions. Fabrice? Arantxa, here's a question for you. Which satellite measurements do you use? Arantxa, can you hear?
Sorry, I was muted.
Yes.
So we have data assimilation. We assimilate satellite observations for the physical product, okay, for the multi-year and for the near real time. And we use the satellites that are available at the moment. I don't remember now, but I think that has shown 3. I cannot remember now the name of the satellites, but we use a product that is in the Copernicus catalog. So if you go to the product user manual, you will find there which is the product, which is the Copernicus product, and we use all the available data that we can find in this product.
Thank you, Arantxa. Have we got another question?
Would it be possible to have forecast wave spectra? Well, I'm not sure about this question. I suppose that in the future it could be a good possibility to improve. We are a user-oriented service, so all the petition, all the requests that you have, it's good to communicate to us. So for the planification of the next phase, we will take into account. The same as with the other 3D data set that was a request from users.
Okay, thank you, Arantxa. Can we have another question? Yes.
I would like to know why there is a hole in the products, just in the southeast of Spain. A hole? I don't know. A hole in the... But which data set? It's not the hourly 3D data set? But there is no a hole. It's a square region. I don't know, maybe if he could or she could send us the question. There is our email is in the first slides, the EB service desk email, and maybe we can take a look of this.
Okay, thank you, Arantxa. So
okay,
please,
thanks very much.
We give the floor to Álvaro.
Hello. Here I just have few slides to show you the tutorials we are prepared related with the modeling products, the physical, the biogeochemical, and the waves product. We have prepared 3 different tutorials, 3 different videos, and 3 different Jupyter notebooks. One of them is for the physical part of the modeling products. Here you have a short summary of the information you are going to see in this tutorial, which is a visualization of the African upwelling using the EV physical products. In this exercise, we are going to focus our attention into the upwelling system occurring in the northwest coast of African continent. And we will use 2 different IB products, IB modeling products, the IB physical analysis and the IB physical reanalysis. So we are going to make a comparison between the results obtained with the reanalysis and the analysis products. We also will visualize maps of SST, of surface temperature in the region to see the upwelling. And we will learn how to visualize time series of SST from Copernicus products, and we will learn how to plot vertical sections of temperature in a specified latitude. For example, here you can see the images we are going to create in our training. In the next tutorial, we focus our attention again in the upwelling system in the Northwest African continent. However, we are using, in this case, the biogeochemical products. To do that, we will use the chlorophyll parameter to see the upwelling in the coast and in the African coast. Here you can see 2 images of the products we are going to produce. images produced from the two different products again. We are going to use the biogeochemical analysis and the biogeochemical reanalysis. So we are going to make a comparison between the different results obtained with the analysis and the reanalysis, and we will give information about why they have the same information but in different way. And excuse me. And in this, the objectives of this session is to visualize maps of chlorophyll in the region, as you can see here. We will do a comparison, as I said before, between EBBO reanalysis and EBBO near real-time products, and also we will produce a visualization of the vertical variability of chlorophyll, which is called a Hofmöller diagram. You probably know about these kind of diagrams. In the x-axis, this kind of diagrams has time, and in the y-axis we will put the depth. So we will see the evolution of the vertical profile of chlorophyll in time. And to finish, the last tutorial we are presenting here is a tutorial focused in the EV wave products. For this tutorial, we are using just the forecast product to have a look of the evolution of different storms occurred in December 2019 in the North Atlantic. Here you can see two different figures that are the figures we are producing in this tutorial. So in this tutorial, the main objectives are the visualization of a scalar maps of significant wave height, which is the left figure you can see here. And we will produce an arrow map also using the variable mean wave direction so that we will be able to see the direction of the waves. Well, that's all we have for these 3 sessions. I think Fabrice has just explained to you how to access these tutorials. We are open. We have some channels to contact if you need anything. If you have questions, whatever you need, we are open. We are happy to answer your questions.
Thank you, Álvaro, for your presentation. Now I will give the floor to Silvia Pardo, who will present the Ocean Color project. Silvia is an ocean scientist at Plymouth Laboratory Earth Observation Group. Please, Silvia.
Hello, Josefina. How are you?
Fine, thanks. And
Thank you very much. So as Josefina says, I'm an Earth observation scientist at Plymouth Marine Laboratory in Plymouth, United Kingdom, and I am part of the Ocean Color TAC. So in this presentation, I will introduce you to the Ocean Color products you can access through the Copernicus Marine Service. We will first talk about ocean color and ocean color variables. I will then show you how we derive ocean monitor indicators from them, and we use them to report on the health of the marine ecosystem, and that's on the annual state report. And then I will finally give you a preview of the different phenomena that we are going to explore during the practical sessions. And first of all, and to make sure that we are all on the same page, I wanted to give you a really brief introduction to ocean color. So as you might know, ocean color is a remote sensing technique that relies on the interaction between the solar radiation and the surface of the ocean. And as you know, the presence of different types of molecules can alter the sunlight as it penetrates the surface of the ocean. And when light interacts with those molecules, 2 things can happen. So the solar radiation can be absorbed as energy, or the solar radiation can bounce back, can be backscattered. So a fraction of this sunlight eventually makes it out of the sea and can be detected using ocean color sensors on board satellites. And the good thing about this detection is that it is spectrally resolved. So the ocean color sensors are able to tell you how much light of each one of the wavelengths or each one of the colors is being backscattered. So we can infer which one of the water constituents is responsible for that light. For example, we have water molecules, and as you know, they absorb all the spectrum except for the blue, and they reflect back the blue, and that's why water looks blue. And then we have phytoplankton, which is a big deal for ocean color, which absorbs the red and the blue part of the spectrum and reflects green light. I won't go into much detail about the internal organization of the ocean color tag, just say that as all of the other Copernicus centers, we are an international group. There are 3 production units, and each one of them has expertise in a different regional sea. And this is actually quite important because each one of the regional seas has really specific biogeochemical characteristics or bio-optical characteristics. So when it comes to ocean color, it's not really one size fits everything, fits all. For example, in here, I'm showing you 2 pairs of images from the Mediterranean Sea. And on the left, you can see the global standard chlorophyll algorithm, that's OC4. And what we found is that OC4 overestimates chlorophyll when compared with in situ data. So we had to develop a regional algorithm, which is called MED-OC4. And that's the one that we use to produce the Copernicus Marine Service products for the Mediterranean Sea. The work that we do on the ocean color tag has basically 3 objectives. The first one is product development. So this is to guarantee that you have access to state-of-the-art data streams. Second one is product quality, which has been mentioned already. And this is to guarantee that the data is the best possible quality, both upstream and downstream. And the third one is the scientific exploitation of ocean color data. So that's to make sure that the data we produce has actually an impact in science and in society. And we will be seeing examples of all these in a few seconds. But first, here we have a quick an overview of the ocean color products that you can access through the catalog. So when we talk about the global model of the ocean, you can talk about 2 components. And the first one is the biological one. And here we have chlorophyll as the main biological variable. And we can use chlorophyll as a proxy for phytoplankton concentration. And then when you have chlorophyll, you can also derive other variables such as phytoplankton size classes or primary production. And then we have a second component. So that's the geochemical component or what we call the optical component. So that's how you can find these products in the catalog. They are called the optical data sets. And here we have variables such as remote sensing reflectances, optical properties, turbidity, suspended particulate matter, transparency, and this gives us information about other water components such as suspended sediments, for example. The ocean color products are available in 2 processing levels, level 3 and level 4. So level 3 gives you a snapshot, a daily snapshot of a region. And for level 4, we aggregate the data for a longer time period. So you have weekly or monthly composites. And also for some of the products, we can fill in the gaps in the level 3 data using interpolation techniques. Then we have 3 processing modes that you might be familiar with. First one is near real time or NRT. So this is produced just after a few hours of acquisition. And to do that, we need to use forecast or climatological ancillary data. Then you have the delay time or DT. These replace the NRT files the day after the acquisition. And it's exactly the same processing chain in all cases, but the only difference or the main difference is that we use actual meteorological observations as the ancillary data. And then finally, you have the reprocessed data sets, or REP for short. And these obviously use the best possible ancillary data, but also uses all the different data streams for all the ocean color sensors. And we aggregate those all together to produce maximum coverage. Each one of these levels obviously is right for a specific application. So we will discuss this, hopefully, if you follow me to the practical session later. We provide different resolutions for different products. So for the regional seas, that's 1 kilometer, and that's determined by the sensor resolution. So it's not something that we choose. And for the global ocean, it's 4 kilometers. And this is a choice because obviously we could be doing global ocean at 1 kilometer, but the files would be huge, basically. So this is a decision based on user experience. We have different models, so to speak, different processing chains for each one of the regional seas. I already have mentioned the need for regional algorithms. So in here, I'm showing you a summary of all these algorithms, all the models behind the different regional and global ocean products. So remember that you have information about all these algorithms in the product user manual that you can access through the catalog. And as Arantxa said, we need to be constantly assessing the performance of the regional algorithms or the regional and global products as we keep acquiring new data. Then we have sensors that are a bit old and they are degrading. Then we have new sensors that are being launched. And in here you have a snapshot of the latest validation exercise for each one of the regions. And we do this every time we make a major change in the processing chain. So this is usually associated with the release of a new rep dataset. And again, you have access to the quality information for both the offline validation exercises, but also the online validation exercises in the product quality documents that you can access through the catalog. So here is a summary of the processing levels and modes that are available and some numbers on data uptake. So this will give you an idea of how our users or the applications that our users are using the data for. As I said, we are constantly working to develop the Ocean Color catalog, and these are the product milestones that we've been working towards in the last year or so. So this includes new data sets, for example, Sentinel-3A, MB Olchi, and Beers now 20. Different improvements in the different products in terms of resolution, new algorithms, and data aggregation techniques. And also new products such as phytoplankton functional types or primary production and ocean monitoring indicators. Speaking about new data streams, this is the ocean color sensor timeline to give you an idea of which sensors were available in the past and will be available in the future. And these obviously are designed by different agencies for different purposes. So looking at this graph obviously poses the question on how we merge the different data streams, how we make a single product from sensors that have different resolutions and different spectral characteristics. Also, speaking about new products, this is an example of the phytoplankton size class product we released last year. And here we use satellite chlorophyll and sea surface temperature to provide specific concentrations for the different phytoplankton size classes. So that's micro, nano, and picoplankton. And similarly, for primary production, which, as you know, is a measure of the chemical energy that gets released into the marine ecosystem mainly through photosynthesis, and it's something that we can derive using ocean color data, sea surface temperature, and altimetry, all from satellite. So to facilitate the use of the Copernicus Marine data, 3 years ago we started developing these ocean monitoring indicators from key biogeochemical variables that we think are really representative of the status of the marine ecosystem. And these are supposed to be useful for regional analysis. They are supposed to be adding context to events and trends, and also highlight the potential correlation between the different biogeochemical variables. For ocean color, the current ocean monitoring indicators include time series, anomalies, and trend maps, if I remember it correctly. Here, for example, is the current chlorophyll time series for the North Atlantic. So chlorophyll has a distinct seasonality in the North Atlantic, at least, and that means that you can extract, so you have the the original daily time series in black. So that's this cloud of points in here. And then you can derive an annual cycle that you can subtract from the original sign. It gives you a deseasonalized time series, which you can see in green. And then you can fit that to a linear trend to provide a measure of the trend that you can see in blue in the plot. And we will produce like a simplified version of this time series during part 2 of the Ocean Color practical. We will also have a chance to look at anomalies and trends during the practical. So in here, for example, I've included maps for the North Atlantic and global anomalies for 2019. And this gives you an idea of how anomalous, how different from normal the chlorophyll was in the North Atlantic during that year. So you have positive anomalies in red, that means that chlorophyll concentration was higher than normal, and then you have the negative anomalies in blue, meaning the opposite, really. And finally, an example of the global trend maps. So that's again the trend map for the period going from 1998 to 2019. We have positive trends in red, negative trends in blue, and these mean that the chlorophyll has been increasing in the range of 1 to 5, or decreasing 1 to 5% per year in the last 20 years for some regions. Once we have a method to derive time series and maps of anomalies and trends, we can apply those methods to basically any ocean color variable. So for example, in here, we have exploited the chlorophyll concentration to provide the boundaries of the North Atlantic oligotrophic gyre. As you know, that's the big oceanic desert in the core of the North Atlantic, which according to observations is getting bigger. Similarly, for primary production, you can produce a time series of the global and regional seas, which have a seasonal cycle, which is quite similar to chlorophyll. And then you can produce global or even regional anomaly maps. And this gives us information about changes in the energy and even the carbon flow through the ecosystem. So last but not least, we try to gather all this information that we derive from the ocean monitor indicators, and we produce an annual report on the state of the ocean, containing a wide range of analysis. For example, in the past, we have studied the correlation between chlorophyll anomalies and climate indexes in particular regions. So, for example, I'm showing here the time series for the El Niño Southern Oscillation in the Pacific Ocean, or the Indian Ocean dipole in the Indian Ocean. We have also reported on the phenology. So that's where and when a phytoplankton bloom starts, ends, where's the peak, what's the intensity. And this is an example where my colleagues have reported on phytoplankton blooms in the Baltic Sea during the past 20 years. The Ocean State Report also gives us the chance to exploit the synergies between different products and the Copernicus Marine catalog. So, for example, in here we have created from Copernicus data an atlas of the Pacific state oceans, including sea surface temperature, ocean heat content, the regional sea level trends, or sea level in general, and chlorophyll concentration. And the Ocean State Report also gives us the opportunity, sorry, that's next slide. It gives us the opportunity to work with users directly. So, for example, this study shows the impact of the chlorophyll decrease on mussel growth in the Northwest European shelf sea. So this is obviously critical for those in the shellfish industry. So almost at the end of my presentation. So to finish, I will give you an overview of the practical sessions you will have access to after this webinar. So I've organized the materials in 3 parts. So parts 1 and 2 will focus on the biological components. So we will mainly looking at chlorophyll concentration. And part 3 will be looking at the geochemical components. So we will be looking or using the optical products. In the first notebook, we will familiarize ourselves with the data. We will have a look at the data structure. We will understand what the variables look like, the dimensions they have, how to extract them, and especially how to visualize them. And this is just an example of the kind of maps that you will learn how to derive. In part 2, we will study phytoplankton bloom. So we will apply everything we've learned and even new techniques to study the intensity and location of a phytoplankton bloom. And we learn how to tell if a chlorophyll value is anomalous or is normal or not. And we will do this for a region, a fantastic region in the globe that is really frequently affected by Saharan dust. So Saharan dust coming from the Sahara Desert contains a wide range of nutrients, and they act kind of like a fertilizer for phytoplankton when they fall from the atmosphere to the ocean. And here's just one of many examples of this effect on this image taken in March 2003 by the SeaWives sensor. And then you can see how the dust is traveling southwest and is basically triggering all these phytoplankton blooms as it goes. And finally, for part 3, we will explore the optical part of the catalog using products that were acquired during a fascinating event that was a subaquatic volcanic eruption near El Hierro in the Canary Islands. And then you have this image taken in November 2011, where you can clearly see the plume, the subaquatic plume going out of the south coast of El Hierro. And in particular, we will try to find the optical signature of this eruption in terms of turbidity, in terms of the changing color of the surrounding waters, and how it affected transparency, and how you can estimate the amount of sediments that were suspended in the waters. So all these processes and events have, obviously, we will look at them from the ocean color perspective, but they have physical and chemical counterparts. So after you're done with the ocean color practical sessions, I will really encourage you to have a look at the other products that my colleagues have presented today or will present today, and see if you can correlate the changes across these sensors. These products, sorry. So this is everything on my side for the time being. I really hope you have a great workshop, and I'm looking forward to your questions. Thank you.
Okay, Sylvia, thanks a lot for the presentation. We have learned a lot about color. Fabrice promises he will do the notebook, so that's great. We have some questions for you.
Lovely, thank you. Sure, yeah. The interpolation technique for level 4 product we use is called DINOF, and you can find the full description, including references to the actual. So obviously, we didn't come up with the technique. We just applied a really well tested and trusted interpolation technique. So you have the description and the references to the original scientific papers in the quality document. And the quality information document that you can access to the catalog.
Okay, Sylvia, the salinity has some characteristic, a spectrum or some wavelength that absorbs?
So salt is very tricky. So salt molecules are too small to be detected from space, basically. But what you can see basically is that salinity obviously has an effect in density, which has an effect on water circulation. So you can see, if not directly the salt dissolved in the water, you can see the effect of a different salinity has on the chlorophyll, for example, because if the water is more heavy, they will go to the bottom. So obviously fresh water will come up to the surface, and that will trigger, for example, a phytoplankton bloom. So you can't really detect it. You can detect it at the lab for sure, but not from satellite at this moment, I'm afraid.
In which Mercator product can we see the size of phytoplankton variable from satellite data?
So the files at the moment are labeled as chlorophyll, but if you go inside the, and I believe at the moment they are available at global level, and they will be available for the Atlantic and I think the Arctic as well from December on. So that's the December release that Arantxa was referring to. We are all of us, we are releasing new products in December. So the files will be labeled as chlorophyll, CHL, but if you go inside them, you will have the different concentrations for the different chlorophyll, for different phytoplankton sizes.
Okay, Silvia, thanks a lot.
Thank you.
We have reached the last presentation, and I give the floor to Fernando Manzano and Paz Rodlan. They will present the in situ observation products. Fernando is a technical leader of the Copernicus in situ TAC for the IB region, and Paz is a programmer and web developer at the SOCID Data Center team. So please, Fernando.
Hello, can you hear me? Can you hear me?
Yes, perfectly well.
Okay. Hello, everyone. Okay. Sorry. Yeah. Let me start with this quote. Without sufficient observations, useful prediction will likely never be possible. Models will evolve and improve, but without data will be untestable, and observations not taken today are lost forever. With this slide, I am only trying to highlight the importance of in situ data and hopefully try to catch your attention. Thank you for being there till the end. This is a short index. The presentation goes from general to specific. Okay, which in situ data are we managing? Well, as you know, the ocean is a complex environment with many phenomena involved. So to measure all of them, it is necessary a multi-platform approach. We are gathering data from vessels, sliders, moorings, argo flows, HF radars, drifters, and the newcomers, the ADCP vessels, and the sail drones. Here, I'd like to take advantage to say that if you know about in situ data that it's not included in the in situ TAC, please let us know, because we are very interested in including it. Here. Now I'm going to talk about in situ TAC. We have two main objectives. Simplifying, the first one is collecting data, apply quality control procedures, homogenizing data, and distributing it. And the second is generating reprocessed products. Both objectives are focused on answers our users' demands, mainly modelers. Now I'll show you some use cases of the in situ data. This is the first one, data simulation. In situ data improves the model outputs. Here, in this example, the simulation of argo flows, it's improving the output of the EV model in temperature on top, and the salinity also. The next example is the climatic characterization. In situ data are used to perform extreme regime analysis, and the results can be used in the design of harbors, for instance. And the third example, it's the, and of course, the model validation. Here you can see an intercomparison between the EV model, the SOCID model, and the HF radar in Ibiza. In this example, it is proof that SOCID model results are better, but I have to say that it is only because EV overestimates as it is created for the Atlantic Ocean and not the Mediterranean. Well, a general description of the service, it's fully operational since 2015, only one data access through Copernicus Marine Service catalog. It's open and free. There exists a strong collaboration with other organizations and initiatives. It's 7 components, global plus regions. We all have the same FTP structure and vocabulary used. Variable, units, attributes, everything, it's homogenized in all our files. The same quality control procedures are applied by all the regions, and we have 2 product families, near real time and reprocessed. The news here is that we have a new format manual, now version 4, that was released in April 2020. This is the schema of the data flow in the EV region, although it could be extended to the other production units. First, data are collected from international organizations and providers through the RUSES, and everything is saved in our database. Then automatic quality control procedures are applied, NetCDF files are generated, and everything is synchronized with other production units, the ones that have overlapping areas. In our case, it's the global, the Mediterranean, and the NOAA shelf. And finally, everything is uploaded to the central dissemination unit to make it available for the users. In parallel, data is scientifically assessed to generate reprocessed products, which are uploaded to the central dissemination unit also. And then at the end, we have an extra layer with cross-cutting activities with common tasks like documentation, product quality stuff, system evolution tasks, contributions to the ocean state report, and our website. Here, some figures, some numbers. around 7,000 platforms active in real time, around 37,000 platforms total, and more than 300 providers. In the dashboard here, you can show that it's only 121 providers, but it's only because it's displaying the active stations in the last 30 days. Now I'm going to talk about the in-situ products. We have, as I already mentioned, two families of products: reprocessed products that are updated twice a year in delay mode, one product, one topic, waves, temperature, salinity, currents. The news in this case is that the new reprocessed products are biogeochemical products with chlorophyll and oxygen, the HF radars and the ADCP mounted in vessels that are included in the current reprocessed product, and the wave spectra that it's expected for this winter. And the near real-time family is updated continuously. It's delayed mode plus near real-time, and it's multi-topic. I'm going to explain later about this product. All the information of a platform is included in the same file. The news here includes the sail drones, the HF radars radials, and the wave spectra that it's already available. Two important documents associated with these products: the PUM, that is the product user manual with a description of the product, and the QUID, with information about the quality, is the quality information document. Okay. Sorry. Regarding this NRT product, I like to explain it better because it's a little bit tricky. Basically, the NRT product is not only a pure near real-time data, but delay mode data also. It will probably be renamed as MyNRT, multi-year near real-time data. It's clear in the last paragraph where it said that this product is constantly updated with the best version of the available data in terms of quality and time coverage. In other words, it is the combination of adding NRT data when there is no rep data available. But if you still have doubts about this product, I'll use a song of the late 80s by Tina Turner to explain it easier. So yeah, it's simply the best, okay? So if you have any doubts about which product to use, this MyNRT product is the best candidate. There is an exception that I explain later. How to work with this in situ data? Okay, all the files are available at marine.copernicus.eu, but at the end, it's only FTP accesses, okay? We are providing index files to facilitate navigation, mainly for automatic tools, and files are organized based on periods, like this. So the latest directory with the last 30 days, one file per day and platform, a monthly directory with the last 5 years, one file per month and platform, a history directory with the whole history of the platform, and then a reference folder similar to the history, but important, it only contains high-quality data, only delay mode data, especially good. So Tina Turner recommended us to use the NRT product, but the exception is just this. In the case you need only top-quality data, then it is recommended to go to this reference folder or the reprocessed products. Each folder has an associated index file, I've mentioned before. And in addition, there is an extra index file with the information of all the platforms included in any folder here. Okay, this is only an example of how the index latest looks like. There is a header and then a row per each file. And this is the index platform. It's quite similar, but there is one line per platform. Regarding the file naming, it's quite simplified in the last times. Now all our files are formed by the region pgram, the file type, the data type, and the code platform. And the last part is the part of the name that can change depending on the file nature. The latest files have a suffix with the date, the monthly files with a month, and the history files commonly nothing, but there is an exception. Sometimes we have to make a distinction there because, for instance, the data is distributed with different time samplings, and in that case, we are going to use this suffix for the historical files. We have changed the format manual, I told you already, but no worries because compatibility with previous versions is kept. I'm not going to go into detail, only saying that our main concern is to improve the homogeneity of all our files. This slide is only to warn about the possible change in the name of the products and the datasets, but as far as I know, it's still being discussed, so my only advice here is to be attentive. And the last section, the improvements in the in-situ tag. I think it's a good one. We have the website, of course. I invite you to take a look and take into account that feedback is important and welcome. So please, if you detect something that you want to improve, please say to us. Well, what's included in this website? Well, the main documentation and some useful code, the key performance indicators, which measures the delay of arrival, the number of platforms, and many other things that could be of interest, and the dashboard that you will in the Chrome. It facilitates data discovery and navigation. It's based on the index files and some metadata. And in the end, there are the FTP links to Copernicus Marine Service. So at the end, you are accessing the Copernicus Marine Service. In my opinion, its use is really recommendable. And I would like to thank Pat, who is in charge of the practical session, because she is the mind behind it. So thank you, Pat. And oh, there is an extra section. Sorry, I lied. But don't panic, very rapidly, only to show something done only in the EB region. It's something that we're doing. This is the Nostromo spaceship. It's an internal tool developed to improve and make the in-situ TAC team's life easier. This map is the main menu of the tool, and each room is dedicated to a specific functionality. Only some examples. This is the control room, used to launch the operative manually and customized. Then this is the hypersleep room, is used to visualize the data included in the distributed nested files. This is the ABIS-VAL in the letter word at the bottom. It's our validation software, which allows us to validate our data in 3 ways. Compare it with nearby stations, with model outputs, and even with satellite data. So it's very good. We are very happy with that. And this is the dashboard to monitor all the tasks involved in the operative. As you can see, it's a very complex procedure, so it's really useful, really helpful for us. And now we've reached the last slide. For me, the most important, as my principal aim today is to show you where we are at the moment. I see it as a Tour de France stage. The first climb was offering a basic service, that is gathering data and homogenize it. This is done. Then we improve the data quality, something that I think that makes us different from other initiatives. It's done also. Later, we developed extra functionalities and cross-cutting services like the dashboard or the websites I already presented. This is done, but improving all the time. And now what we are doing is to be focused on giving good feedback to providers. I think it's really important, demonstrating that having the data in the in-situ TAC works. For instance, we are even notifying the providers about possible failures in their stations most of the time before they notice on their own monitors. So I think it's really good. And that's all I wanted to say. Now Pat will present the practical session. Thank you.
Yes, thank you, Fernando. I was answering a question right now in the chat. Apologies. And well, my part is to present you the material we have prepared for you to start working with the in situ data that is available in the Copernicus Marine Service. The first thing we have done is to provide 7 videos, and in 2 of them in particular, we present some useful tools that you have online for exploring the products. And I think it's going to be interesting for you to at least have a look to these 2 first videos. The other ones, the rest of the videos are just me running the notebooks so that you feel more, guided through all the material and you don't feel alone when running the notebooks. And regarding the notebooks, what we have prepared is first thing an overview of the EB near real-time product, which is the one available in the region, containing in situ observations. And in this overview, what we intend is for you to evaluate if the product is suitable for your needs, so that we explore the kind of variables that are inside this product, also the kind of platforms and these kind of things. In the second notebook, what we do is to give you some functions and useful tips about how to subset the product so that you only download the files that contain the data you are looking for example, because it covers a specific time range, or because it contains a specific variable, or things like that. So I think these 2 notebooks are the most important ones. That's why they are highlighted here. And then we are dedicating some extra notebooks in actually opening and reading and even plotting data coming from certain platforms. In this case, we focus on tugboats, gliders, and sail drones. So in the next slide, I just put some snapshots of the things we are going to do. And as you can see, here you can find some plot from gliders, also from sail drones, in interactive maps, and also videos, because something I find interesting is to actually introduce you the platform that is reporting the data, so that you put a face to the name. And in here, I just put an example of a video talking about what is a tugboat, but you will find also other videos talking about what is a glider and what is a sail drone. So I hope you enjoy the material. Please use the chat enabled by Mercator for asking anything if you have some trouble. I just put an alarm to be there right on time to answer. And that would be all for in situ.
Okay, Paz and Fernando, thank you for your presentations.
Mm-hmm.
Now I guess we have a few questions for Fernando. Is there a way to see the number and location of in situ profiles used to validate a model in a particular area?
I think Fernando is out of he cannot speak. He's not among the...
No, he's not here now.
Authority, yes, but I can answer.
Great.
I have already provided don't worry. We are computing some metrics about the products that we produce, but right now we are providing the number of profilers, which is the platform that is providing profiles. So not exactly the number of profiles. That's something I wanted to let you know. Nevertheless, in the notebook number 1, in the one about the overview, you can actually check in a particular area the data available, and maybe select the profiles and see how much is available. This doesn't mean that a given modeler is going to be using all this data. Maybe they have certain requirements and they are going to use some of the data available, but not all. Okay, it's just to be clear on that.
Thank you, Paz. Another question?
Welcome.
How do you integrate the glider data?
So the glider data is entering the system through Coriolis, who is the one managing the global networks for all the in situ products. So the answer is through Coriolis. Yes.
Thank you. Well, I guess that's all.
Okay.
Thank you, Paz.
Welcome.
Please. Well, I guess Fabrice has some problems. Well, we have reached the end of the presentation. Fabrice is going to talk about another survey that he will show you now before saying goodbye. We hope that you have enjoyed the session. It has been a pleasure being with you here today. And we encourage you to work on the notebooks and to ask all the questions that you need to ask. Now, Fabrice, I has a problem. He cannot.
Hello, guys.
Vincent?
I think, Fabrice, you have your micro on. Maybe if your
Well, I believe
camera is
I'm
not
here on my
working, you
own.
can speak.
So this is the survey. We encourage to reply. Please, it's short, and we need your feedback. It's very important for us.
Qu'est-ce qu'il me fait, lui?
I can hear somebody. I wonder if it's you, Vincent.
Hello?
Is it?
Hello?
Yes.
Yeah, sorry.
Fabrice has got a problem.
Yeah, sorry,
Can you
I'll
hear
take
me
the
now?
lead. Fabrice has problem of connection.
Okay,
I would
we're
like
talking
to...
about the survey.
Oh, Fabrice is back. Fabrice,
Can
can
you
you
hear me?
speak?
Yes.
Perfect,
Yes,
thank you.
yes, at last.
Okay, sorry for that. So we are just 10 minutes late on our agenda, but okay, it's quite fine.
That's great.
After
It's great.
After 2 hours and a half of webinar, I hope you enjoyed this webinar. I hope it was a fruitful workshop for you. As Josefina said, we encourage you to practice the Jupyter notebooks and to interact with the speakers and trainers through the chat. Don't hesitate to contact us. You have the email address to contact all the training team. I would like to thank you, Josefina, for your presentation and your work during this workshop. Thank you very much.
A pleasure.
It was a pleasure.
Thank you.
To moderate this session with you. Thank you again, Vincent, to solve all the technical issues. And thank you again, all the presenters and the trainers to involved in this training to participate. Thank you all. I guess this is the end. So have a nice day and see you in 2 weeks for the debriefing session. Bye.
See you.
Bye.